Hi students, this is the third video on solubility. So we just talked about how substances and mixtures are different, and then we went into how we can dissolve different types of substances. And so now what we're going to do is talk about how the temperature can affect the amount of dissolved solids. We talked about the amount of dissolved gases with temperature, but now we're going to take a look at solubility with solids. So we all know this, that we can dissolve substances in water. Um, and some substances, particularly really concentrated substances, can harm organisms. So we have to monitor that by testing the water quality all the time. All right. So I want you to do something for a second. I want you to imagine that you have a water solution and you're adding some sort of salt, for example, sodium nitrate, and you're in the lab here, and you're stirring it into the water, right? And the solid white crystals of that potassium nitrate, they dissolve and make a solution, all right? But it's colorless and it's clear after it's dissolved. What would happen if you add a bit more to that particular solution? Well, you might not know unless you try it, right? You have to put in a little bit more. There are two answers that could be correct. One answer could be that you actually dissolve more. So the more you add, right, the more it dissolves. Another answer might be that it gets to a point where the water in the solution can no longer dissolve that potassium nitrate. In that case, you've hit what's called the saturation point, and you can no longer saturate or dissolve any more of that solid. So there's some terms here that we want to use, right? So when we're talking about solubility, we want to talk about how we dissolve one thing into another, right? And the thing that we dissolve is the solute. The dissolved substance in the case above is called potassium nitrate. That dissolves in water, so therefore water is the solvent. And together, the solute and solvent makes a solution, which again is a homogeneous mixture of two or more substances, in this case, water and sodium nitrate. I put a picture there off to the right. Again, the thing that dissolves is the solute. The thing that dissolves the solute is the solvent, right? In this case, water. And together, those two, once they're dissolved, make a solution. Okay. So I just used a term like saturated, right? When I am thinking about the end of the week, I am saturated with Zoom calls. In other words, I have had my fill. I can't take another Zoom call. Maybe you feel the same way. So saturated means that a solution has the maximum amount of solute dissolved in the solvent. So solubility, right, that word really is the maximum amount of solute that can dissolve in a solvent at a specific temperature. Um, Unsaturated or not saturated means that you could dissolve more solute in the solvent. Unsaturated means you haven't yet gotten to the point where you've added the maximum amount that would be dissolved. It says there a solution that contains less dissolved solute than the amount of the solvent can normally hold at a given temperature. And I keep saying temperature, you keep seeing this temperature. Temperature also changes the amount of solute that can dissolve in the solvent. So we often draw what's called a solubility curve. which is a graph of the relationship between the mass of the solute that dissolves in 100 grams of water and the water temperature. As you can see in this graph here below, you have the temperature that's on the bottom x-axis, and you have the amount of grams of the solute dissolved in 100 grams of water. And what do you notice? What is the relationship? Well, for the three substances you have there, as temperature increases, the amount of solute that can dissolve in that solvent, water, can increase too. An example, at 40 degrees Celsius, right? So right here, the maximum amount of sodium nitrate, which is right here, this line, right? The maximum amount that 100 grams of water could hold is 60 grams. How did I figure that out? Well, I went up to here, right? I went from 40 up and I hit the line. And that line represents the maximum amount that can dissolve. And I read over. That was 60. Okay. So anything that is on that line, right, the amount of solute, if you have that amount at that temperature in the solvent, you are saturated. You can't add any more. Okay. If you added less than that, let's say you added 50 grams at 40 degrees Celsius of KNO3 with 100 grams of water, you would actually be unsaturated. In other words, you could add 10 more grams. Okay. If you added more than that, let's say that you had, 70 grams at 40 degrees Celsius, what would happen is 60 of those grams would dissolve. You would see that happen. And then you would keep stirring and keep stirring and keep stirring and keep stirring. And no matter how much you stirred it, there would still be 10 grams left that would not dissolve. It would just stay as a crystal. Okay. And so it's important to sort of imagine this, right, happening. Once you get to that saturation point, you have no more that you can dissolve at that temperature. Now, what could you do? How would you be able to dissolve more, right? The answer is simply heat it up. So if I tried to dissolve 70 grams of KNO3 at 40 degrees, only 60 grams would actually dissolve. The rest would not. But if I just heated it up to say, I said 70, so if I go over, I see that 70 is at about 45 degrees. So if I heat this up 5 more degrees, I would be able to dissolve that last 10 grams. Okay. So that's just an example of how temperature can change the amount of stuff you can dissolve. So if you really want a sugary drink, like a tea or something, you want to add a lot of sugar, what do? You add the sugar after you heat it up, not before you heat it up. If you add it after you heat it up, you can add a lot more sugar and it will dissolve. Now, a funny thing happens. Sometimes you can make what's called a super saturated solution. That sounds pretty cool, right? A super saturated solution is where you have a solution where you heat it up, you add a lot of the solute, and then you cool it down really quickly. What that does is if you don't disturb it at all, you can have more solute that's dissolved than what the temperature actually dictates, right? So if you put in 70 grams at 45 degrees, but then you let it sit and let it cool off to 40 degrees, you would actually create a supersaturated solution where 10 extra grams were dissolved in there. The thing is, it's not very stable, as you can imagine. So if you bump it just slightly, or if you add just a little bit more after it cools off, all of the extra that can't dissolve at that temperature will immediately come out. And so it's pretty cool what it looks like. I'll show you an example here. Of course, it's taking forever. So yeah, so this is actually the process where you have a super saturated solution. And again, this is a super saturated solution here. If you add just a little bit of extra to that, it forms these crystals here. And all that, those crystals are the extra solute that it couldn't dissolve at that temperature anymore. It's actually quite beautiful. This is also how you make rock candy. So if you ever want to make rock candy, there are easy ways of creating rock candy based on this, where you heat it up and then you cool it down. So that's the gist of it. There are some practice questions here that you can go through on your own. These are just asking you guys to sort of read the graph. And these are some specific questions that you can answer here. I give you the answers right here in the video.